In last video, we discussed about the introduction about operational amplifier, and now we will discuss about ideal op-amp and their characteristics. What is mean by ideal op-amp? The other name for ideal op-amp is differential amplifier. So differential amplifier, it can perform the difference of both the voltages. So as we already know, op-amp consists of two input signals. Here V1, V2. These are the input voltages. The ideal differential amplifier, it can perform the difference between these two voltage sources, V1 minus V2. So V0 output voltage is directly proportional to V1 minus V2. So we generally termed the difference, we generally term V1 minus V2 as difference voltage V. Okay. V0 directly proportional to V1 minus V2. We can replace V1 minus V2 as Vd, since it is a difference voltage, Vd. Then the differential amplifier consists of three important parameters we are going to discuss now. First one is differential gain, AD. So now we will study about the differential gain, AD. How the AD term is came suddenly. In previous step, V0 equal, not equal, directly proportional to Vd or V1 minus V2, right? So to eliminate this proportionality, we have to reduce equal to, and we have to reduce one more constant term. So that constant term, here AD is the constant term. AD is the gain. We assume this gain, AD differential gain, is our constant term for the proportionality. Okay. Where AD is the constant of proportionality, AD is the gain with which differential amplifier amplifies the difference between two input signal. Hence it is called differential gain of the differential amplifier. So this AD is called differential gain. So we can write like this: V0 equal AD. Instead of V1 minus V2, we can write Vd itself, differential voltage. So V0 is the output voltage, AD is the differential gain, and Vd is the difference voltage. Hence the differential gain can be expressed as differential gain, AD. We can write it as V0 divided by Vd, right? So this Vd will come downwards. Generally, the differential gain is expressed in its decibel value. We have to mention the value of differential gain in dB, decibel. How to write this value in dB? AD equal we have to take 20 log 10 base 10 AD. So if you take 20 log 10 of AD, we can transform into decibel form decibel units. So we can represent it in decibel units like this. The next parameter is common mode gain. If we apply two input voltages which are equal in all the respect to the differential amplifier, that is, here we are having two different voltages, V1 and V2, two different voltages, so we can perform difference. So we can get any number of values, any value we will get. But assume that both the voltages are equal, V1 equal to V2, okay? This V0 equal to AD V1 minus V2. So both the voltage equal to means it will get 0. V1 minus V2 are, sorry, V1 minus V1 or V2 minus V2, 0. So V0 equal to 0 in a common mode. In common mode, both the voltages are equal. So we will get output voltage as 0. But the output voltage of the practical differential amplifier not only depends on the difference voltage, but also depends on the average common level of the two inputs. Such an average level of the two input signals is called common mode signal, denoted as VC. Okay. So what is VC? VC is the average voltage. V1 plus V2 divided by 2. So this is the average voltage. VC. Average common mode signal, VC. Average common mode signal VC. So V1 plus V2 by 2. Therefore, output voltage is not only depends on common gain, but also average voltages, common mode voltages. Thus, there exists some finite output for V1 minus V1 equal to V2. Due to such common mode gain AC in case of practical differential amplifier. Okay, but theoretically V0 equal to 0. Okay, but practically we can have some amount of common mode signal, average common mode voltage, that is called VC. So V0 equal to AC VC. As so the total output voltage output of any differential amplifier can be expressed as V0 equal to difference mode gain AD VD plus common mode gain AC VC. Okay, then when the third important parameter is common mode rejection ratio, CMRR. When the same voltage is applied to both the inputs, the differential amplifier is said to be operated in a common mode configuration, as we already know. Many disturbance signals, noise signals appear as a common input signal to both the input terminals of the differential amplifier. Such a common signal should be rejected by the differential amplifier. So hence the parameter called common mode rejection ratio. The common mode rejection ratio is involved common signal, commonly referred to as a noise, unwanted signal, we have to reject. The ability of a differential amplifier to reject a common mode signal is expressed by a ratio called common mode rejection ratio. It is defined as the ratio to the of the differential voltage gain AD to common mode voltage gain AC. So ratio between differential gain to common mode. CMMR generally termed it as a rho. Many times CMMR is also expressed in dP. Any parameter we have to express in dP only. So CMRR in dP, how CMRR in dP, how we can transform? We are already know we have to take 20 log then. 20 log. 20 log of AD by AC. So log 10 we will eliminate, so it will become invert. AD will come upward and AC will come downward. This is dP. 20 log AD by AC dB. The various features of differential amplifier are high differential voltage gain, low common mode gain, high CMRR, two input terminals, high input impedance. It exhibits large bandwidth and low offset voltages and currents. Also, it exhibits low output impedance. So in this video, also we will discuss about the characteristics of op-amp, the difference between ideal op-amp and real op-amp. Okay, so in ideal op-amp, infinite open loop gain, we will exhibit infinite open loop gain, and in real time op-amp, limited open loop gain, and it also infinite bandwidth. In ideal, we are having the infinite range of frequencies. Here we are having limited bandwidth, and also in ideal op-amp, we are experiencing infinite slew rate. Here we are experiencing finite slew rate. So what is meant by slew rate, and the detailed explanation of the slew rate, input impedance, zero impedance, that and all we can discuss in the upcoming videos. Okay, because these are the characteristics involves AC and DC. And also this is the op-amp equivalent circuit. So inside the op-amp we are having this is the internal circuit. So resistance we are having internally we are connected this resistance in an op-amp. And summary of characteristics: common mode gain, bandwidth, input impedance, output impedance, that and all ideal op-amp how it can realized, and typical op-amp how it can perform. So like this. So in this video we have seen the introduction about ideal op-amp or difference op-amp, and also the difference amplifiers parameters, differential mode, common mode, and common mode rejection ratio. So in the upcoming video, we will discuss about DC characteristics of op-amp. Thank you.